Assalamualaikum everyone. Selamat sejahtera. Apa khabar? Semua sihat-sihat ya? Okay, so today we are going to do a little bit of revision from the first topic that we have covered until to the last lecture. Okay, so let's start. Okay, the first thing that we have gone through adalah we have seen analog signal processing block diagram and digital signal processing block diagram. As you can see that for analog signal processing, you have the analog input signal into the processor, going into the processor, and the output is also analog signal. And for the digital signal processing, you have the analog input signal because all the real world signals are analog. And so it goes into ADC, analog digital converter, which actually contains, the ADC contains the sampler, the quantizer, and also the coder. So the sampler basically takes the data, samples the data, and then the quantizer basically quantize the amplitudes of the continuous signal into a discrete signal, discrete numbers, and the coder codes the signal into binary data, and it goes into the memory of the digital signal processor. So basically, the data that goes into a digital signal processor is digital, and the output of a digital signal processor is also a digital signal. And then when it comes out from the DSP processor, it goes into a digital analog converter, or any kind of output that you want to observe your signal. Okay, so you can print directly the digital signal print it out, or you can display it on a screen or LCD, whatnot. Okay, so the main thing is the ADC. Okay, but you have to understand, okay, the digital signal goes into the DSP processor, and the output is also a digital signal. All right. The sampling process, okay, we know that the analog signal is given by XAT equals to A cos omega t plus theta, which is the phase. Okay, so the capital omega is defined by 2 pi f. So f capital F, and then the discrete time signal is given by xn equals to A cos omega n plus theta, and the small omega is also defined as 2 pi f. So you can, as you can see here, the definition ataupun the definition of the signals are very similar, but you will see that there are differences in terms of how to differentiate between the analog and the digital signal. Okay, so the components are similar. So the amplitude is denoted by A, and then the function is the same, cos. Okay, but the frequency omega, so the capital omega is for the analog, and the small omega is for the discrete signal. So it's 2 pi f. Capital F is for analog, small f is for discrete. Okay, and then remember that the discrete signal is denoted by n, okay, which is the sample number. Now, the relationship between the analog and the discrete time signal is given by T equals to N capital T equals to N over Fs, or simply, if you want to remember it easily, is T equals to N over Fs. So N is the sample number over the sampling frequency. Now, the analog signal, okay, when you replace or substitute the T with N over Fs, okay, if you substitute the T with N over Fs, then you will have Xn. So that's basically how easy it is to convert from the analog signal into discrete time signal. So simply change the small t okay, into n over fs, okay, right. The Nyquist sampling theorem is given by fs equals or bigger than 2f max. So fs is the sampling frequency, 2f max is 2 times the highest frequency component in the signal. So the so in practice is basically higher than 2, okay, but the theorem says 2f max. If this sampling theorem does not is not being followed, so there will be aliasing. All right. Now, if we look at an example from the lecture that I have given to you, so we have two analog signals, okay, x1t equals to cos 2 pi 10t and x2t equals to cos 2 pi 50t. So what is the corresponding discrete time signal or sequences when sampled at fs equals to 40 hertz? As you can see, in the first signal, x1t, the frequency is the f is 10. So according to Nyquist sampling theorem, the minimum sampling frequency is about 20. Okay, and for x2t, the f is 50. So basically, the minimum sampling frequency would be 100. So basically, you can see that with 40 hertz as the sampling frequency stated in the question, x2t will be, there will be aliasing. All right. So once you solve this, so the question begs you to write what is the corresponding discrete time signal. Okay, what is the corresponding discrete time signal? So here, as I've mentioned before, so we need to change, we need to substitute the t with t equals to n over fs. So simply substitute the small t with n equals to t equals to n over fs, and you have for x1n cos pi n over 2, and for x2n we have cos 5 pi n over 2. And then if we plot the signal, okay, if we plot the signal by simply, I've used here Excel just for a very fast plot. Okay, so you can see that x1n equals to cos n pi over 2, and x2n is cos pi 5 n pi over 2. All right, so for n equals to 0, so the value x1 is 1. So n equals to 1, the value of x1 is negative 0.000204, and so on. Okay, so basically we just substitute the value of n with the sequence, the sequence of n 0 until whatever number, whatever length the signal is given. All right, in this case, I just simply put as 12. Okay, you can make it as 10 or 5. Okay, as you can see from the plot that that is next to this table, is the x1n and the x2n actually is quite similar. Okay, when you plot it, and even though in the table you can see that the signals are have some dissimilarities, but if we look at it in the big picture, it is very similar. And if I put this plot together, it will actually overlap, and you will not see any difference. Okay, so you can try this easily using Excel. Okay, all right, so basically this is how you can plot your signal and see whether it is aliased or not. Okay, or you simply want to see the new sampled data. So basically from the signal, digital signal, the discrete time signal or digital signal that we have obtained, simply change the n from n equals to 0 until a certain number of samples. All right, so there are two types of discrete signal that we always use as an example, or as a system response, okay, to check our signal, okay, to check our system, okay, to check our system, and to, as we use as an input, or we use as as an input, or as the response from the system. So two basic types of signal, which is the impulse signal, that delta n. Okay, so impulse signal is just one signal at n equals to 0. Okay, delta n is one signal with the amplitude of 1 at n equals to 0. Okay, step signal un, okay, is normally a signal that is from n equals to 0 until infinity, and the amplitude is 1. So it is it's infinite signal. Okay, so but basically the amplitude is 1. So this is where we want to check our system, okay, because the amplitude is 1. So there's no problem with when you multiply or you add up, when you are doing adding or any kind of operations on the system. Okay, so these two signals you must always bear in mind. Okay, so the basic operations of a signal, okay, or in a system, you have the addition, you have the adder or summing junction. So you can see that in the summing junction, you have two different signals, or two signals goes into a summing junction, and it is being added. Okay, so in this example, xn plus wn, the output is yn. So you have to be aware of the direction of the arrows. Yeah, and then you see that there's a multiplication operation. You can see there's a multiplier that is denoted by a. So yn equals to a times xn. And then you see there's a product modulator, where xn times wn. This is where there's a sequence, okay, a sequence times with a sequence, okay. Right. The difference is, okay, that the multiplier is a constant, multiplies with a sequence of numbers, but in a modulation operation or product mod operation, a sequence is times with another sequence. So that is the difference. Yeah? Okay, so and then you have the time shifting operation. So there's two types of shifting operation. You have the delay or the advance. Okay, so delay is when you have z to the power of -1, and advance is just z. So once a signal goes into a delay, okay, so in this example, xn goes into z to the power of -1, a delay. So the xn becomes xn minus 1. If it goes into another delay, then it is xn minus 2. So it depends on how many delays. You can see this through the videos that I've shared with you on the revision for basic operations. Okay. And then there's the time reversal or folding, where the operation is denoted by yn equals to x minus n. Okay, and then there's the branching operation. So branching operation basically copies the signal that goes into the node. So means that if xn goes into a node or goes into a branch, it branches out. It becomes copies. Yeah, it becomes copies. So do not mistake this with summing junction or any kind of other operations. Okay, branching is basically a node. Okay, a node that makes copies of the signal that goes into the node. So xn goes into a node, it comes out as xn. Xn also, it still comes out as xn. Okay, and then we have seen that the process of decimation, where you have in this example xn to x to n. Okay, so basically the easiest way to do this decimation process is to use a table. Okay, so you list out the n and you list out the xn. Okay, in this case, in this example, the decimation of 2n, that means that the signal becomes much smaller. Yeah? So you have to remember that bila it is 2n, so means that the n must be divided by 2, not darab dengan 2. It has to be divided by 2. So you have to divide all the n's by 2. And so you have the value of negative 1.5, negative 1.0, and so on. Okay. So the amplitude of that signal remains the same because we are only manipulating the time parameter, not the amplitude. Yeah. So the amplitude remains the same. So in discrete signal or digital signal, the n must be integer. So any non-integer n's must be cancelled out. So you are left with only negative 1.0, 0, and 1.0 for the n. Okay, so basically that is where you have your final signal. So for expansion, means that we are zooming into your signal or we are making it bigger. So basically, you have to, in this example, xn, we are going to expand it to n over 2. So xn over 2. So the process is again similar. So you list out all the n's and with the amplitude in the table. And then all the n's, okay, even though this is n over 2, so but again, you have to multiply it by 2. So multiply all the n's by 2. Okay, when you multiply the n's by 2, so you have your new n's, which is negative 6, negative 4, negative 2, 0, 2, 4, 6. Okay, and then the amplitudes remain the same. Okay, but the signals is already expanded. So this is a time manipulating the time parameter. Okay, so the precedence of signal operations, when you have a lot of operations going on, so you need to know which one you have to do first. So step 1 is you need to remove any inner parentheses in the xn. Okay, so if there is any inner parentheses in the xn, you have to simplify it. Okay, after that, you need to do a time shift by the factor b, and then a scaling by the factor a, and then you have to apply folding. Then you apply folding for if there is folding. Okay, all right. Okay, so before that, all right, in this example, okay, xn over 2, sorry, let's do look at this example. Okay, so x2n is a decimation, but 2xn means that you have to multiply the amplitude with 2. Okay, so saya repeat lagi if x to n maksudnya dia decimation, so you kena buat proses ni. Kalau dia 2xn maksudnya you kena darab semua amplitude dengan 2. So lain So kalau dia values dia dalam bracket, dia lain proses dia kalau berbanding dengan kalau values tu di luar xn. So kena ingat tu, kena bezakan. Okay. Now, the basic sequence ni can be represented in the time domain, a weighted sum of some basic sequence and its delay advances. So ini dinamakan sebagai difference equation sebenarnya. So if you have a sequence of numbers, macam in this example, so you have you can write it as a form of a summation. Summation. But it doesn't mean that kita boleh tambah semua value-value ni. Bukan, dia hanya menunjukkan bahawa there is a sequence of numbers because you cannot actually simply tambah because there is a bracket here. Okay, so you can see that this is all impulses. Yeah, this is all impulses, which has impulse kan dia satu kan. The value of impulse is only 1. So basically here, kalau you tengok the first term 0.5 delta n plus 2. Maksudnya dia berada di n negatif 2. Okay, n negatif 2 dengan dia punya amplitude adalah 0.5. So maksudnya 0.5 darab dengan 1 lah jadi 0.5. So you can write this into an equation. So you see that here the first 0.5 delta n plus 2, maksudnya lokasi dia adalah 0.5 di lokasi negatif 2. 1.5 delta n negative 1. So maksudnya di lokasi n equals to 1 adalah amplitude dia 1.5. Okay. Dan dekat sini adalah value dia negatif 1. Okay. So dia tambah negatif 1 di lokasi n equals to 2. Okay. And so on. Okay. So kena faham yang ini basics, the way that we write this. Because impulse adalah satu saja. So kalau ini lokasi, kalau delta n maksudnya lokasi dia di n equals to 0. So kalau n plus 2 maksudnya n di delta n berada di lokasi negatif 2. Kalau n minus 1 maknanya delta n tu berada di n equals to 1. Okay. Ini kita berbalik kepada basic operations yang ada delay tadi kan. Okay. Alright, so this is how we can write, kita boleh tuliskan dalam bentuk equation. Alright, so seterusnya, okay, if we look at another example, we are going to look into several examples, because I did not emphasize this in my lecture, so I will emphasize it here. So for example, if we have two signals, okay, we have x1n and then we have x2n. So given the signals above, the difference equation for each signal is x1n sama dengan delta n. You tengok delta n berada di n kosong kan? Okay, n kosong value dia 1. Impulse mesti value dia 1. Plus delta n minus 1. So lokasi dia berada di 1. Okay, value dia, amplitude dia 1. And then we look at x2n. So x2n dia berada di sebelah kiri So delta n plus 2, okay, n plus 2 tambah dengan delta n plus 1 and 2 delta n sebab dia punya amplitude adalah 2, okay, 2. So kalau katakan if yn equals to x1 minus n, which is folded x1 plus x2n, then apa yang kita kena buat dulu, kita buat satu-satu. It's not difficult. So you have x1 minus n. So kita terbalikkan dia kan, kita fold. So when it's folded, so this it will be delta n plus 1 plus delta n. Okay, and then x2n remains the same. Then we add these two signals. Okay, we add these two signals. So x1 minus n plus x2n. Okay, so kita gantikan persamaan ni, persamaan yang kita dah define earlier, masukkan ke dalam persamaan ni. Okay, so kita tengok delta, so x1 minus n equals to delta n plus 1 plus delta n tambah dengan delta n plus 2 tambah delta n plus 1 tambah 2 delta n. Okay, so kalau kita tengok dekat sini, paling kiri sekali adalah plus yang paling besar, okay, which is delta n plus 2. Okay, so kita tengok ada berapa banyak delta n plus 2, so ada satu saja, so delta n plus 2. Then plus delta n plus 1, so ada berapa delta n plus 1? Ada 2, so 2 kita tambahlah, so jadi 2 delta n plus 1. And then kita tengok ada tengah dia adalah delta n, so ada berapa delta n? Ada 3, so ada 3 sebab delta n plus 2 delta n jadi 3 delta n. So if we write it in a sequence of numbers, okay, so you can see that it is 1, 2, and 3, dengan 3 berada di n equals to 0. And so we can also check this using a tabular method. Okay, so you tuliskan dalam bentuk table, okay, lukiskan dalam bentuk table. Basically, you boleh tulislah dia punya X1N ni. Okay, so kita tahu bahawa X1N, kita dah X1N adalah yang dah default. So semua daripada sebelah kanan jadi sebelah kiri. Okay, dan kita ada X2N yang sama macam asal lah. Okay, dan kita tambahkan. So kita dapat 1, 2 dan 3 sama macam yang kita buat tadi. Okay. Right, so then kita, this is, so you boleh tulis lah, so this is the sequence of yang kita dapat. Okay, so you can check with that. So either you buat the tabular method ataupun you buat the equation method, dua-dua boleh. Okay, will give you the same answer. Alright, now the next example. Okay, so if this is soalan ni, this is from the lecture. From the lecture, so I took about 4 of these questions and I explaining to you now how you get the answer. Okay, so example number 2, you have x1n plus, the question is yn equals to x1n plus x2n minus 3. Okay, so maknanya x2n kita kena delay dia 3 unit. Okay, 3 unit. So what you have to do is, bila x2n minus 3, so daripada yang signal asal tadi tu, semua you minuskan 3. Semua yang dalam n tu, you minuskan 3. And then you simplify, so you dapat x2n minus 3, delta n minus 1 plus delta n minus 2 plus 2 delta n minus 3. Okay, then you tambah. Okay, you buat the same process, the same process. Okay, and then you punya signal at the end ni, you dapat sequence dia S1 2 1 2. So kalau kita check dengan guna kaedah table ni, so kita tengok X1N, okay, X1N, and then X2N minus 3. Okay, so kalau kat sini kita tengok kita nak delaykan dia 3 kali kan, daripada ruang 3, 1, 2, 3. Okay, then you letak you punya signal. Okay, delaykan dia 3 kali. Alright, so you see here, bila you tambah signal ni, you will have the same output. Okay, so maknanya samalah. Okay, example seterusnya, okay, adalah if yn equals to delta n minus 3 plus x2 minus n plus x1n plus 2. Okay, so dekat sini you tengok, dia akan maksudnya ada 3 signal. Kita ada x2n yang folding, dan kita ada x1 yang advance 2 sampel. So kalau kita tengok dekat sini, and then you have delta n yang delaykan sebanyak 3 sampel. So here you have x1n plus 2. So maksudnya semua n tu kena plus 2 lah. Ambil x1n yang asal dan plus 2 semua n tu. And then you simplifykan dalam tu, you have your x1n plus 2 bersamaan dengan delta n plus 2 plus delta n plus 1. Okay, then you tengok x2 minus n. So you kena fold kan all the, you kena foldkan semua n tu ke sebelah kiri lah. Okay, sebab dia dia daripada kiri ke kanan lah, sebab folding kan. Okay, so dekat sini you kena foldkan signal tu. Alright, so here okay. Okay, so dekat sini you foldkan, means that all the ends ni, okay, you kena tolak 1. Okay, then once you have your signal, okay, you have your signal yang you dah buat tadi, so you tambahkan lah. Okay, you gantikan delta n minus 3, you masukkan balik dalam persamaan yn tadi tu. Okay, buat proses yang sama, maknanya delta n minus 3 plus x2 minus n plus delta x1 n minus 2, x1 n plus 2. So gantikan semua sebutan dalam bentuk delta kan. So delta n minus 3 plus 2 delta n plus delta n minus 1 plus delta n minus 2 plus delta n plus 2 plus delta n plus 1. Okay, so kita tengok yang paling kiri, yang paling besar iaitu plus, mana plus yang paling besar? Plus 2. Okay, so kita tengok plus 2 yang paling berapa kali ada plus 2? So ada satu saja, dan the next one adalah plus 1. So berapa kali ada plus 1? Okay, ada satu saja. Dan selepas tu adalah delta n, iaitu minus 0. So delta n saja. Ada berapa delta n? So dekat sini ada 2 delta n. Okay, 2 delta n. And then negative 1 pula. Okay, n minus 1. So ada berapa n minus 1? So ada satu saja. And then tengok minus 2 ada berapa? Satu saja juga. Minus 3 ada berapa? Ada satu saja juga. Okay. So then you boleh then once you have done that, okay, kita boleh tengok you tulis dia punya amplitude saja kan, value amplitude saja, sequence of numbers dia. So dekat sini kita tengok sequence of numbers dia adalah 1 1 2 1 1 1 with the 2 being the n equals to 0 kan, sebab 2 delta n means that n is at 0. So the amplitude at n equals to 0 is 2. So therefore, sebab tu ada arrow dekat number 2 sini. Then again, we can check with the tabular method. Okay, guna table. Okay, so you have x1 n plus 2. Okay, x1 n plus 2. Then x2 minus n. Okay, then you have delta n minus 3. Okay, so delta n minus 3 ni kena gerak 3 kali lah. 1, 0 hingga 0 ke 1, 1 kali, 1 ke 2, 1 kali, 2 ke 3, 1 kali. So 3 kali delay. Okay. So then you tambahkan semua, then you have the same values as yang you buat tadi. Okay. Now example seterusnya, example 4. Given the signals, the difference equation for each signal adalah x1n. So dekat sini soalan dia adalah yn equals to u minus n plus x2n. Okay, so saya dah tersilap kat sini. Patutnya saya letak x2n kan, tapi saya terletak x1n pula. So kita fokus dekat soalan ni. So u minus n. So u ni selalunya, so u minus n ni adalah step function tadi. So katakanlah sebab dia un ni adalah infinite punya signal. So daripada n0 kepada n equals to infinity. So kalau katakan kita just give a rough kita redefine balik u ni. Okay, so kita letakkan sebagai un equals to 1 pada 0 hingga 3. Okay, 0 hingga 3, dan yang tempat lain semua jadi kosong. Okay, so kalau kita buat begitu, then we have un, sebab 0 hingga 3 je kan. So un equals to delta n plus delta n minus 1 plus delta n minus 2 plus delta n minus 3. Okay, sebab kenapa saya guna delta n? Because it's still impulse, because dia adalah value dia adalah 1 pada n yang berbeza kan. So that's why it is still delta n. Bukan saya yang guna but it is the definition of that. So any signal that has the amplitude of kita semua discrete signal, basically kita namakan dia, we use delta as the representation of the discrete signal. Okay, and then when we multiply it with a number, then dia akan berubah amplitude. So any signal that is discrete, kita represent with delta. So dekat sini, once you have the delta n ni, okay, then you fold. So u minus n, so you kena fold lah everything, instead of positive, instead of minus, jadi plus. Okay. Alright. Then, okay, so dekat sini saya tulis x to n. So x to n, kita ada x to n. Then we have our u minus n. Okay, so kita tambahkan values yang, sequence ini. So you have u minus n, letakkan persamaan itu, plus x to n. So again, the method is the same. Cari plus yang paling besar sekali. Dekat sini adalah plus 3. So delta n plus 3. Ada berapa kali delta n plus 3? Ada satu kali sahaja. Dan the next one adalah plus 2. So plus ada berapa delta n plus 2? Ada 2. So ada 2. Dan kita tulis itu 2 delta n plus 2. Dan kita tengok delta n plus 1 pula. Ada berapa delta n plus 1? Ada 2 juga. Okay. Yang ni kena buat slow-slow, jangan salah. Kalau salah, okay, habislah. So 2 delta n plus 1. Dan kita tengok delta n. Okay, so delta n ada berapa? Ada 3 delta n. So nak minus tak ada kan? So minus tak ada. So kita boleh tulis kita punya sequence of numbers as 1, 2, 2, 3. Okay, perkali dia 1, 2, 2, 3. So the 3 being n at equals n at 0. N at 0. Again, kita boleh check dengan secara tabular method. Okay, so saya just tulis saja un tadi tu. So un saya tulis dulu, n kita define daripada 0 hingga 3 kan. So dia value dia adalah 0 hingga 3 je tadi. And then kita buat folding. Okay, dan kita tulis balik x to n berapa dan kita tambah. Okay, tambah u minus n dengan x to n dengan x to n. So kita dapat values yang sama dengan cara kita buat tadi. Okay, so basically that's how we can cara kita tulis equation untuk signal. Alright, so please bear in mind that one. Okay, then after kita dah pergi pada basic sequence, pada basic operations, kita pergi pada convolution. So convolution ni is a mathematical operation yang kita nak expresskan hubungan di antara the input and the system. Okay, the input and the system, which is a linear time invariant punya system. Okay, so input is always represented by xn. The system is always as hn. Okay, and the output is yn. Okay, so when in convolution, it's being used in because it shows ataupun it's a process of this system and signal. So that's why dalam proses buat filtering, okay, kita gunakan convolution. Kita gunakan convolution. So here you can see this is the process, the low pass filtering bila kita darabkan signal input and the system response. And then in discrete convolution, so it's given by yn equals to xn convolved with hn, xn being the input and hn being the system. Okay, so there is 4 operations involved in this process of convolution: the folding, the delay, multiplication and summation. Okay, when you tengok dia punya persamaan, persamaan mathematics dia. Alright, so there are basically 2 ways of doing convolution lah. So basically direct convolution or kita buat secara summation. So kalau kita tengok dekat sini, okay, for example, kita dah you are given a sequence, 2 sequence of numbers, okay? Sebab kita punya the input and the system response is always represented with a sequence of numbers, and so xn equals to 0, 1 to 1. Which can also be represented by the difference equation. Okay, the difference equation delta. Kalau kita tengok dekat sini, delta n minus 1 sebab kita start dengan because delta n is 0, so kita tak tulis dalam equation. Okay, so that's why kita start with delta n minus 1 plus 2 delta n minus 2 plus delta n minus 3. This is from the example yang kita pernah bincangkan in our lecture. So that's why I ambil saja value yang ini. Tapi kalau you tengok, so because we want the I don't want to use the arrow here, so that's why I just put 0 kat situ, because the first number yang sebelah kiri tu will be your, bila tak ada arrow, the first number on the left it will be n equals to 0. Okay, so and then we have the system impulse response, which is also a sequence of numbers. Okay, then it is 2 to 1 1. Okay, which can be represented with a difference equation juga. Okay, so what will the output response of yn? Okay, apakah rupa bentuk yn? So we have discussed this in rather detail in our lecture. We use the sliding ruler method or tabular method, where you write the table. Okay, tuliskan table tu, tuliskan n, yang penting tulis n, delay tu, and then the sample number, which is k, -3, -2, -1, yang the first row. That the first row is k. The first row is k, which is sample number. Ingat kan, kita dah because n is delay, therefore k will be your sample number. Okay, so dekat situ. Okay, so you write the original, you write down the original signal first. Okay, kat mana original tu, which is xk. Okay, and then hk, the original signal for the system. Okay, it can be terbalik pun tak apa, because it's a sequence of numbers. So it's distributive, bukan distributive, as communicative, so dia boleh tukar. So dia ada then dekat sini, so in convolution you kena buat folding dulu. Okay, so we take the hk and fold the signal. So ingat, folding it happens at k equals to 0. In this example, k equals to 0. And then apa yang berada di sebelah kanan pergi belah kiri pergi belah kanan. Okay, now, okay, so you need to buat delay. Alright, you need to delay the samples. So basically, because in this case, in this example, kita start dengan kita terus delay sahaja, kita terus delay sampai habis. Okay, so in this example, so kita delay the samples ni daripada kedudukan asal dia, okay, kepada yang the last sample must be aligned with the first sample of the first sequence. So when we want to start convolution, okay, after you dah buat folding, so you have to delay the sample, the second sequence, okay, yang paling akhir mesti the sample yang paling akhir mesti align dengan sample pertama, sequence yang pertama. Okay, so kalau you tengok dekat sini pada n-2 ni, okay, n-2, okay, you nampak tak dia punya hujung sample tu align dengan xk. Okay, hujung sampel align dengan xk yang pertama. Okay, so berapa kali you anjak signal ni, itulah you start dengan delay yang itu. So dalam case ini, kita anjak 2 kali untuk mendapatkan alignment yang ini. So that's why kita letak situ -2. Okay, so once you have done that, baru kita buat darab. Kita darabkan setiap sampel dengan setiap sampel ini dan kita tambah. Okay, so kalau you tengok dekat situ n-2 yang kedua tu, yang kedua. So yang pertama tu saya just nak tunjukkan delay 2 sampel ke kiri. Kemudian n-2 ni saya nak tunjukkan yang di situlah kita mula darab, So kita darab dan tambah. So dalam case ini, okay, there is only one sample and this sample is being multiplied with 0. So that's why y -2 equals to 0. then we have to, after that, pada n equals to -1, we shift the signal to the right. Okay, we shift the signal to the right, and then kita multiply again. Okay, we'll multiply, and then we buat summation. Okay, and then we do that until the first sample of the second sequence align to the last sample of the first sequence. Okay, kalau you tengok betul-betul. So please look at this carefully. We have already discussed this in detail. Okay, and then this is the sliding ruler or tabular method. This is what is important here is the n, okay, and then the sample number, which is the k, the xk, hk, h minus k, h minus 2 minus k tu tak payah pun tak apa. Tapi xk, hk, h minus k tu kena. So yang lain tu tak, then the rest you have to write down. Okay, once you have that values, okay, then you boleh tulis yn, dia punya sequence of numbers lah, apa yang you dapat. Okay, this is one method. So the other method is using the, salah je difference, maaf ya. Kita boleh convolvekan difference equation tu. So Hn darab terus dengan Xn, okay. So Hn darab terus dengan Xn. So you tengok dekat sini, kalau bila Hn darab dengan Xn, so Xn kita gantikan dengan difference equation yang kita dah define tadi. So Hn will be, so all the delta, okay, so all the delta will be replaced by H. Okay, you can see that all the delta is being replaced by H. And then, so for each of these terms, you kena gantikan dia punya sebutan Hn. Okay, so if you look at Hn tadi, okay, kita dah tengok Hn tadi apa. So Hn ni, you kena gantikan dalam sebutan ni. So for instance, so Hn minus 1, so means that you kena delay semua Hn tadi tu, you kena minus dengan 1. Minuskan dengan 1. And then, so then the next term is 2Hn minus 2. 2Hn minus 2. So dekat situ means that all the delta tu, you kena minus dengan, all the n's minus dengan 2. Okay, all the n's minus dengan 2. Dan semua equation tu kena darab dengan 2. Okay, and then term yang ketiga, sebutan yang ketiga adalah Hn minus 3. So Hn minus 3, you tengok dekat situ, so all the n's must be, all the n's for Hn kena tolak dengan 3. Okay, so you have to write this down tau, bukannya baca je, you have to write this down, and then you have to maybe write it multiple times. Okay, and then you simplifykan sebutan dalam parenthesis tu. Okay, so you have delta n plus 1, delta n, then 2 delta n minus 1, and so on. Okay, and then you buat benda yang sama juga macam kita dah pernah buat tadi, So cari plus n plus berapa yang paling besar sekali. So dekat sini n plus 1 is the plus yang paling besar. So you start with n plus 1, then n, then n minus 1, n minus 2, n minus 3, n minus 4. Okay, once you susun macam tu, then it's easier for you to write down the sequence of numbers, which is actually the same as apa yang kita dapat dekat if we do the tabular method. Cuma there is pros and cons of each method. Okay, so you choose which one you nak buat lah. So there's 2 ways of doing convolution. Okay. Then we went into correlation. So correlation is basically to measure the similarity between two sequences. So kalau kita tak tahu apa yang if the two sequences are the same, okay, we use correlation. Okay. And there are two types of correlation. There is cross-correlation, there is autocorrelation. Cross-correlation meaning that we are checking the two different signals, and autocorrelation we are checking into two the same two signals which are the same, but one is delayed. One is delayed. So that is correlation. And if we look at this summary, you can see that convolution is a process that we have two different sequences, and satu sequence you have to fold first, then you have to you tengok dekat dalam gambar tu. So dia punya hujung dengan yang pertama tu mesti align dulu, and then you convolve, you delay, baru dia complete the convolution. And then you see the cross correlation and the autocorrelation. So cross-correlation is between two different signals. The process is the same but without folding. And autocorrelation is two of the same signal. Two of the same signal. Okay. And then kita tengok pula pada properties of linear time invariant system. We have looked at commutative, distributive, associative. Okay. So dekat sini commutative, you can see that hn equals to yn, which is equals to hn xn yn. So this is the same as yang tadilah, masa yang convolution yang saya bagi tahu tadi. So commutative, yeah. And then we have cascaded commutative, then we have distributive. So distributive means that if you darabkan setiap sistem tu xn times h1n, and then xn times h2n, and then you sum it together, is the same as when you have it in one system. If you have it in one system. So that is distributive. Then we looked into classification of linear time invariant system. Okay, you tengok pada linearity, time invariant, causality, stability, and memory. So untuk linearity, so it obeys the superposition principle. So what you need to understand is, here, if you have, you tengok diagram ni, or you can, you tengok diagram ni. So you see here, you have x1n and x2n going into a summation junction and goes into the system. It is the same as if you you put one signal into the system, and then you put another signal into the same system, and then you tambah. Okay, so it is the same. Kalau kita tengok dekat sini, example dia, if we have, so we need to determine whether xn kuasa 2 ni is linear or not. So what you need to do is you need to substitute xn with x1n dengan x2n. Okay, so you need to use two inputs to verify whether a system is linear or not. So xn kita gantikan dengan x1n plus n x2n. So dekat sini xn tu kita sebutan the term xn is replaced by x1n plus x2n. So we have yan equals to x1n plus x2n to the power of 2. All right. And then we have to expand this equation. So once we expand the equation, then we have to do another comparison, which is ybn equals to y1n plus y2n. Okay. So ybn equals to x1n to the power of 2 plus x2n to the power of 2. Okay, so and then we compare yan and ybn. So since it is not the same, so the system is not linear. Okay, right. Then another example. Okay, so we have yn equals to xn plus 2xn minus 1. So again, we have to substitute the xn. So the input must be two different signals, which is x1n and x2n. So in this yan, so we have to substitute all the xn with x1n and x2n, x1n plus x2n. Okay. This is referring to the diagram yang I dah tunjuk kat you in the beginning tadi ya. So all the xn must be substitute with x1n plus x2n. Okay, once you substitute that, okay, you have to simplify the equation. Then we have to do y1n equals to apa, y2n equals to apa. So means y1n maknanya input dia hanya x1n. Y2n input dia x2n. Oh sorry, ni ada typo sikit So you tukar nanti So all the x patutnya y2n equals to x2n plus 2x2n n minus 1. Okay. So bila kita gabungkan, so ybn equals to y1n plus y2n. So if it's the same, then means that the system is linear. Okay. Now, for time invariant, so we need to see whether the system bila ada time parameter yang berada di time parameter yang explicit yang explicit, dia adakah sistem itu akan berubah atau tidak So we need to check that. So what we have to do is we have to delay the input and we have to delay the output. So kalau we are given yn equals to 1 over 2 xn plus xn minus 1, okay, what you need to do is to delay all the inputs. Inputs dia apa? Input dia adalah xn. So xn ni kita delay by nd. So all the xn must be delayed by nd. So here ni pun ada typo juga ni. So dekat sini you see that when you delay all the xn, so you get 1 over 2 xn minus nd plus xn minus 1 minus nd. Okay, so all the inputs are delayed, and then what you need to do is to delay the output. So when you delay the output, all the ends, okay, all the ends, bila kita delay output, all the ends must be delayed. Okay, dekat sini, when we delay all the ends, then kita bandingkan, we compare yn minus nd equals to txn minus nd. So if it's the same, then the system is time invariant. So dia tidak berubah mengikut parameter masa yang explicit. So the easiest way to see whether the system is time invariant or not, okay, one of the methods is kalau katakanlah yn equals to 1 over not 1 over 2, but maybe n times xn plus xn minus 1. So n tu berada di luar, so then you have a time a system that is not time invariant. Okay. So go back to my lecture, my recordings, if you want a better explanation of the time invariant. So and then we've looked into causality. Okay, so causality involves current and past input values. So basically any future values tu kita tak kira sebagai dia causality. Then we have stability, basically whatever system that is not infinite, the input is not infinite, the system is not infinite, or the input is not infinite, then the system is stable because it is bounded, bounded input and bounded output. Why is it important to have a system that is bounded, but BIBO, bounded input, bounded output, is because it's for practicality reasons, tak nak crash of this computer. So kalau you tengok dekat sini examples ni, if you have this yn, example 1, output yn only depends on 3 values of xn at different n. If xn input tu adalah bounded, means kalau katakan you guna impulse sahaja, impulse signal, then you have an impulse response that is bounded sebab dia hanya ada satu, dia punya n is finite, dia tidak sehingga ke infinity. Or dia punya, if you use a step input yang tidak di bound, okay, means that the n adalah daripada 0 hingga infinity. That means the system, okay, will be a a system that is not stable lah. Okay. And in this example pun sama juga. So kalau you tengok dekat sini, if in this example, bounded input does not ensure bounded output, because if you have bounded input, katakanlah you gunakan bounded input impulse, tapi k equals to 0 hingga n infinity, then sama juga so dia tidak stable. So and then we looked at memory. So a system is with memory if it consists of non-current input. So kalau dia ada delay, kalau dia ada advance, that means it is a system with memory. So okay, I think that's it. Okay, itu sahaja. And if you have any other questions, boleh tanya saya, tak ada masalah, bila-bila boleh tanya. Then I hope this revision helps you understand what we have covered so far. Okay, so thank you. Good luck for your exam tomorrow. Bye.